All right, welcome back. This is Unit 4.1, Solving by Factoring. All right, Unit 3, we factored all over the place, but now we're going to solve factoring. So looking back, maybe last year in Sec 1, you did a lot with linear equations, where we had something like y equals mx plus b. So let me just write that there. Y equals mx plus b. Okay, and then I imagine you also wanted to find out what the x-intercepts are. Okay, so x-intercept is where the line crosses the x-axis. And when we did that, we would set y equal to 0, because if we look at like a y equals x, this is y, this is x, where the line crosses the x-axis, the y value will always be 0. So we would substitute 0 in for y, and we would end up getting something very similar to this, where m is the slope and b is the y-intercept. This is intercept form. Okay, so we'll be kind of doing the exact same thing except using quadratics. So let's just get started. So it says, what is a quadratic equation? Okay. Well, a quadratic equation, we've kind of talked about that before. At least we talked about quadratic expressions. So maybe we should talk about that first. What's the difference between an equation and an expression? Because when we factored, we just used expressions, something like ax squared plus bx plus c. Okay, but when we're talking about equations, the only difference is that we're going to have an equal sign. Okay, so if we had an equation, kind of like we did with the y equals mx plus b, mx plus b, for a quadratic, it would be y equals ax squared plus bx plus c. Right, where a, b, and c are just coefficients. They could be 0. So you could end up even having a quadratic that looks something like this, y equals x squared. Okay, that would also be a quadratic equation. All right, so what is a quadratic equation? Well, it is any equation with an x squared, okay, if you're using x as your variable. If you used v, then it'd be v squared, or you could choose any variable, okay? Where x squared is the highest exponent, okay? All right, and when we're solving, we'll kind of do the exact same thing, all right? We talked about with linear equations, if we wanted to find the x-intercept, all we would do was set that equal to 0. And we'll do kind of the exact same thing when we're trying to solve quadratics, okay? We'll set x equals to 0, and we're going to try and find what those x-intercepts are, okay? Because it's a quadratic, there will always be 2 solutions, always, okay? So if you're doing your homework or doing a quiz or a test, and all you write down was 1 solution, you're just missing half of the problem, okay? So make sure when you have your solution, you always have 2 solutions, okay? And we'll talk about how we write those down, and yeah, it'll be great. All right, so like I said, in this unit, we'll be focusing on solving quadratics. Our next unit, Unit 5, we will be graphing them, and that will get us through the entire term. So these units are a little longer than normal, so it's important that you stay caught up and have your homework turned in on time. Okay, if you have any questions, I expect you to come and get help or raise your hand in class so that you can get caught up. Okay, if you had a hard time with factoring before, it's not going to go away, so you need to come and talk to me. All right, there's different ways to solve quadratics. But no matter what you do it, you'll get the same answer, okay? The reasons why we have different ways to factor is because sometimes these methods, like factoring, doesn't work every single time, okay? And so we'll spend a whole unit or a whole section or lesson on which method works best for when. Okay? So anyways, let's keep going. So remember, before you begin factoring, and this is the same thing, we haven't covered anything. There's only one really small thing that we're going to be covering new. Okay, but just like we did before, we should always have our expressions, they should be in standard form. Okay, and we're talking about like ax squared plus bx plus c. So standard form, we have the highest exponents first, and then we have our middle term, if possible, if there is one, and then our constant. Okay, and sometimes there's not a b, sometimes there's not a c, but for quadratics there will always be an x squared. Otherwise it wouldn't be a quadratic. Okay, and then it also says if the leading coefficient is negative, we have to factor that out. That has to be our greatest common factor. All right, so let's do a quick review of factoring. Okay, so this basically covers everything that we did in Unit 3. All right, so if you can, pause and see if you can do this by yourself. Okay, first thing, you should always check and make sure it's in standard form. Okay, for A, B, C, and D, they're already in standard form. Step 2, we need to see if there's a greatest common factor. Okay, for A, there's not a greatest common factor. For B, there is a greatest common factor. That would be 2. For C, there's not a greatest common factor, and D, there's not a greatest common factor. Okay, after that, we would do our glasses, would multiply the first and last term, 9p squared, and we'd need to find two things that would add up to give us our negative 10p. Okay, so two things that multiply to give us 9 and add to give us negative 10. Probably the easiest, you can always list things if you get stuck, but this would end up giving us a negative 1x and a negative 9x. Okay, if we multiply those together, that gives us a positive 9x squared, or sorry, p. All right, and then if we add those together, that gives us negative 10. In Unit 3, we talked about if a equals 1, the leading coefficient is 1, then we can use the shortcut. We would make those two parentheses, and we would put our p's in, and then we'd plug in our negative 1 from here, and our negative 9 from here. Okay, so this would be fully factored. A way to know that it's fully factored is we don't have any exponents. Okay, so for B, we figured out that we can factor out a 2. That would give us 2 times b squared minus 6b minus 27. All right, and then we do the same thing as we did in example A. So negative 27b squared. We need to find two things that multiply to give us that and add to give us a negative 6b. All right, so I think there's only two choices to multiply to give us 27, is 1 and 27, or 3 and 9. Okay, so it's obviously going to be 3 and 9, because there's no way we could make 1 and 27 to give us a negative 6. So here would maybe realize that we'd do negative 9b and a positive 3b. All right, and again, since we took out the greatest common factor, our leading coefficient would be 1, so we can use the shortcut. We'll have our 2 there, have our two parentheses, we'd have b's, and then we'd plug in our negative 9 and our positive 3. Okay. All right, next, you may look at this and say, well, we could do glasses, but probably the easier way if you realize that this is the difference of squares. Difference meaning we have a subtract, okay, and these are both perfect squares. So in class, we talked about how we can just take the square root of those two terms. That would give us n and 9. And then our signs are just positive and negative. Okay, and then D, here we can't take out a greatest common factor, so we just have to go straight into glasses. That gives us negative 18x squared, and they add up to give us negative 17x. Okay, again, since this is negative, we know that this is the difference between those two numbers. Okay, and there's only thing that's going to make that work would be 1 and 18. So we'd need negative 18x and a positive 1x. Okay, and then since a is not 1, a here, a is 2, so we would need to substitute this in for negative 17x. So we'll have 2x squared minus 18x plus x minus 9. Okay, and then we'd need to group. So we'll cut it in half. The greatest common factor for the left side would be 2x. Greatest common factor for the left side would be 1. So we'd end up having 2x leaves us with x minus 9. And then we have our plus 1 times x minus 9. All right, so these, the parentheses, what's in the parentheses are the same. So we put that in one parenthesis, x minus 9, and then everything else would go in the other parenthesis. Okay, so that was a quick review of what we did in Unit 3. This was basically everything that we covered. All right, so let's keep going, okay? We still haven't learned how to solve, okay? So again, whenever we're actually solving, we have to have an equation, and this is just an expression. If it had a 0, that would be an equation, okay? So we'll get into that. Okay, so let's consider this. If a times b is equal to 0, then what does a and b have to be? Okay, so you may realize that either a has to equal to 0 or b equals to 0. Okay, that's the only way that will actually happen. Okay, so this is the same as if we factor a quadratic. Okay, we have one parenthesis and we have another parenthesis. This could be like your a and your b. Okay, to have this equation equal to 0, either this has to be 0 or this has to be 0. So we would want to write this down as x minus 2 is equal to 0, or x plus 3 is equal to 0. Right? Okay, so, and then from there, we could actually solve for what x is. So here, if we needed to, we could add 2 to both sides, or we could subtract 3 from both sides, and would end up getting x equals 2, or x equals negative 3. All right? And oftentimes we will write those solutions like this. X equals 2, comma, negative 3. All right? So really, once you factor the quadratic equation, which is what we've covered, this is all Unit 3. All you have to do for this lesson for today is set each factor equal to 0 and solve for x. Okay? Okay, and just a quick reminder before solving, one side of your equation must be equal to 0. Okay? And the equation must be in standard form. Okay? All right, so here's some steps for solving by factoring. Say we have an equation that's something like this. 2x squared plus 14x equals a negative 20. Okay, so the first thing that we should always do is put it into standard form. Okay, so here what we would do is we would subtract 20 to both sides, and that's what we'd get in our next line. Okay, next step is to factor. Factor out the GCF first, and then we do glasses, and this is what we would end up getting. Once it's factored, we're going to set each factor, so here's one of our factors, here's another factor, and set them equal to 0. And then solve for the variable. Okay? So let's just do some examples, and you should be set to go. Okay? So please, I would suggest pausing and doing these by yourself, or at least try and do some of them. Some of these are a little different, so I would pay attention to help you out. Don't assume that everything we've covered so far is enough. So I don't know. Anyways, okay. But I would pause and give it a try. See what you got. If you run into problems, then watch the rest of the video. Okay. So first thing we'd always want to do, standard form, check. GCF, none. Okay, so we'd go straight and do our glasses. Give us 14k squared, 9x. Okay, find those two things that will multiply and add. Okay, and we'd maybe come up with 7k and 2k. All right, since a equals 1, we can go straight to our parentheses. We'd do k plus 7 and k plus 2. And then we would need to set each of those factors to equal to 0. So k plus 7 is equal to 0, and k plus 2 equals 0. We'd subtract 7 from both sides, and subtract 2 from both sides. And that would leave us with k equals -7, k equals a -2, or we'd rewrite it as k equals -7 and a -2. Okay, when a equals 1, you may notice that these values are the same. They're just different sign. Okay, and you could use that if you would like. There'll be other problems where it's not, when a is not 1, you can't just do that. Okay, so I would not skip steps, but I know some of you will do that anyways, and I just want to make sure you know the limitations of what you're doing. Okay, so here's another one. Standard form already, no GCF. 6n squared, -7n. Okay, that will end up giving us a -6n and a -n. All right, again, a equals 1, so we can use the shortcut. n minus 6 and n minus 1 equals 0. We'd set those set the factors to 0. So n minus 6 is equal to 0, and n minus 1 is equal to 0. Would add 6 to both sides. That gives n equals 6, and would add 1 to both sides. N equals 1. So our solution here would be n equals 6 and 1. Okay, do not put parentheses around those two. It's not an ordered pair. It's not a point. Okay. All right, let's do the next one. All right, so first thing, standard form, check. GCF. All right, there is a GCF, so don't forget, if there's a leading negative, we need to take that out. So if we take out a -1, and we divide everything by -1, that would leave us with -x squared plus 4x plus 4 equals 0. And then we would do our glasses. So 4x squared equals 4x. That would give us 2x and 2x. So we'd end up getting x plus 2 and x plus 2. and then we'd set each of those factors equal to 0, so x plus 2 equals 0, and we have x plus 2 equals 0. We'd subtract 2 from both sides, and we get x equals -2 and x equals -2. Okay, so you could write this as x equals -2 comma -2. All right. Next, standard form, check. Greatest common factor. Okay, there is a greatest common factor. So what is that greatest common factor? We can take out a 7 and we can take out an n. So we'd have 7n, and what's left in our parenthesis would be n minus 1. Okay, so we need to set each factor equal to 0. So we could do 7n equals 0, and we could do n minus 1 equals 0. And then to get n by itself on the left side, we'd divide both sides by 7. That would leave us with n equals 0. Okay, 0 divided by 7 is just 0. And then on the right side, we would add 1 to both sides. And that would leave us with n equals 1. So our solution that we'll box will be n equals 0, 1. Okay, so again, there's always two solutions. Always two solutions. All right, okay, E. The first step, standard form. This is not in standard form, so we'd need to add 2 to both sides. That would give us 6k squared plus 7k plus 2 equals 0. Okay, there's no greatest common factor. So, and since a equals 1, or a equals 6, we're going to have to use the longer way. All right, so we'll get 12k squared, and 2 things that multiply to give us that, and also add up to give us 7k. Could give us 3 and 4, so 3k plus 4k. Again, since a is not 1, we need to substitute that in. So we'd put in 3k plus 6k, or sorry, 4k. And these are still the same, 6k squared and plus 2. And then we'll do it by grouping. So what would be the greatest common factor for the right side? You could factor out a 3, and you can factor out a k. That would leave us with 3k times 2k plus 1. And then on the right side, looks like we can factor out a 2. So we'd have plus 2 times 2k plus 1. Again, we can always know that we did this right because these are the same. That's our new greatest common factor. We can factor out 2k plus 1, and then everything else would be 3k plus 2 equals 0. Okay, so this is a good example of where you can't just go really easy and find what this two solutions are. Okay, here you would want to set each factor equal to 0. Okay, and then we would need to solve. So here we'd subtract 1 from both sides. That gives us 2k equals minus 1. And then we'd divide both sides by 2. And we'd get k equals -1/2. Just kind of covered that. And we do the same thing on the right side. So we'd subtract 2 from both sides. And that gives us 3k equals -2. And then we'd divide both sides by 3. And that would be our other solution. So our final solution we'd write as k equals -1/2, comma, -2/3. Okay, and the order of these doesn't matter, okay? All right, so that's probably the hardest factoring problem that you'll have, is where you have to do the grouping. But, I mean, that's not the new part. The new part is just setting each of these to zero and solving, okay? And that's the same thing you did with linear equations, finding the x-intercepts. So these are the x-intercepts, all right? Except you have to do it twice. Okay, so let's do another example. So please, if you continue, if you are trying to do this by yourself and then checking, that would be fantastic. Okay, again, standard form. So we need to subtract the 3 from both sides. So we have one side is equal to 0. So x squared minus 25 equals 0. Here you may realize that this is one of those special cases. It's the difference of perfect squares. So different perfect squares here, this is our difference. These are our perfect squares. That means we can square root both of these. And what's going to go in these parentheses is going to be our x and our 5 for both parentheses. And then, since it's the difference of squares, one of them is going to be positive and one is going to be negative. If you wanted to factor, you can do that as well, okay? So our two solutions will be x plus 5 equals 0 and x minus 5 equals 0. Subtract 5 from both sides, we get x equals negative 5. And then if we add 5 to both sides, we get x equals a positive 5. So our solution would be x equals negative 5 comma 5. Okay. All right, next one. It's not in standard form, so let's take care of that first. So we'll subtract or add 5 to both sides. That would give us negative n squared minus 9n minus 18 equals 0. All right. Next, greatest common factor. There is a greatest common factor. We'd want to factor out a negative. Oops. A negative, and then divide by a negative. So that would give us negative, and then in our parentheses, n squared plus 9n plus 18 is equal to 0. And then we continue. I mean, again, this is nothing's new here except to the very end where we need to solve. So here we'd have 18n squared, add up to give us a 9n. Those two things would be 3 and 6. So 3n plus 6n. Since the leading coefficient here, a equals 1, we can use the shortcut. Just keep your greatest common factor still in the front. So we'd have n plus 3 and n plus 6. And then we need to solve. So we'd do n plus 3 equals to 0, and n plus 6 is equal to 0. Subtract 3 from both sides, n equals negative 3, and subtract 6 from both sides, and we'd get n equals negative 6. Okay. And then h, I think this is the last one. Yep, last one. Okay, so again, standard form, we need to take care of that. Okay, and that would gives us 10r squared plus 19r plus 7 equals 0. We can't take out a GCF, so we will just go straight into our classes. That would give us 70r squared. They need to add up to give us 19r. All right, and that may take a minute to figure this out. You can always start listing things you could do 1 and 70, but that won't get us 19. Or you could do 2 and 35. that won't get us to 19. 3 doesn't go into 70. 4 doesn't go into 70. Next would be 5. 5 goes in 14 times. And that would give us 19. So we'd have 5r plus 14r. And again, since a here, the leading coefficient, a is not 1, a is 10, we would need to substitute this in. So we'd do 10r squared, that's the same, and we do plus 5r plus 14r plus 7 is equal to 0. We'd do our grouping. Greatest common factor for the left side, we could take out a 5 and an r, so 5r. And what's left would be 2r plus 1. And on the other side, the greatest common factor would be 7. So we could take out a positive 7. What would be left would be 2r plus 1. So we know that we did that right because what's in the parentheses is the same. We factor out the greatest common factor, which is 2r plus 1, and everything else would go in another parenthesis. So 5r plus 7 equals 0. Then we just need to set each factor equal to 0. So 2r plus 1 is equal to 0, and 5r plus 7 is equal to 0. Okay. Subtract 1 from both sides. 2r equals negative 1. Would subtract 7 from both sides. We get 5r equals negative 7. And then we divide both sides by 2. We get r equals negative 1/2. And if we divide both sides here, we get negative 7/5. Okay, so that's everything. Again, it's a little tedious because we've already done this before, but the only really different part is just setting each factor equal to 0 and solving for x. Okay, if you have any questions, let me know, and we'll see you later.